Building the Future, Green Building in the New Millennium, brought to you by Sustainable Homes of the Future. Our natural world is in crisis. We need solutions now. Join the conversation today. Well, thank you everyone for joining us today at Building the Future, Green Building in the New Millennium. I am very thankful to have with me today Nate Adams. You can find him on YouTube as Nate the House Whisperer, we'll talk about why that is today. He has a number of different businesses and is affiliated with a couple movements, Electrify Everything, as well as HVAC 2.0. I'll ask you more about those, but welcome, Nate. Thank you for being here.
Glad to be here, Ian. Thanks for having me.
For sure. I wanted to kick it off. We'll talk about those two movements and how those have come about. But you asked me before we hopped on here if you could tackle the word sustainability. So why not? That's a great place to start. What is your working definition of sustainability, and how does that program at your work?
So personally, I find the word really frustrating now. Because it doesn't mean all that much in a lot of cases. It's a little too broad. Sometimes It's been, pulled to mean two different things. It feels to me a lot like the word green, which doesn't really have a good definition anymore. Maybe it did around 2000, maybe 2005, and then it felt like it kind of got co-opted. So I love the idea of sustainability, if I don't necessarily like the word sustainability.
So what do you think of when you approach a project, whatever that may be, whether it's looking at electrification of a home, or it's designing an HVAC system, or it's, working on some of the campaigns that you're doing to bring education and awareness to people in the industry, as well as the general populace and clients, obviously, specifically, where does that sustainability filter, find its way into your work, or what do you envision when you think of sustainability as it relates to you?
So it's an interesting way to get there. We view it as a byproduct and not a goal.
I like that.
Just as efficiency is usually a byproduct. So what we are usually aiming to do is figure out what bothers a client about their house. Because a lot of people, if you dig into it, just 2 weeks ago, we had a client. She uses their bedroom as her office, but the rest of the house is cold. And she said, if the rest of the house could be as comfortable as my office, I'd never want to move. That's a really key thing to know. So I want to know what makes it comfortable.
Yeah.
Why do you like that room? And then try and peel it apart so that I can begin to figure out what's it going to take to make that house awesome. So we'll keep touching on it, but the HVAC 2.0 process, it's an entire process. And the easiest way to look at it is it's like nursing for houses. I won't say it's like doctors, because doctors actually have a crappy process in a lot of cases. You can
we're in agreement on that.
Easily. Yeah. But nurses, they have to solve problems quickly and well every day, repeatedly. So they have a process. It's called ADPI. They assess the problem. They diagnose the problem. They plan what the solution is. They implement the solution, and then they evaluate if that solution worked. And so we have that built in to our process. So like, do you have mold problems? I want to know about that. When and where. Do you have bugs coming in? I want to know about that. When and where, what kind of bug? Do you have drafts? Where does that happen? So the more we can pull the clues together, it also makes me think like Scooby-Doo. Ooh, a clue. Like people just leave that stuff lying around. Lousy murderers if they're leaving clues around for teenagers to find.
Yeah, you could be Nate the House Detective as well as the House Whisperer, I suppose.
Kind of, yep. So what we're trying to do is we are trying to create a Venn diagram. So there's 3 circles in the Venn. There are what the client goals are. There's what the budget is for the project, and there's what their house needs. Because if you can't get those 3 circles to overlap, you don't have a viable project. And also those circles need to overlap with good odds of success. Because do you want to spend 15 grand for 50-50 odds?
No,
I don't.
definitely not.
Now, if you're talking 80-85% odds, okay, like we're to the point where we could probably tweak it. But buildings are complicated things.
Yeah.
Like they're a system of systems that work together, and you change 2 or 3 things and you drastically change how the rest of it works. And that works for ill and for good. So we work very hard to understand what is it going to take to get good odds to solve the problems that our clients want to solve.
Yeah.
And if we do that, part of how the whole heat pump thing ended up coming to be was heat pumps have lower output capacities than furnaces. So the smallest commonly available furnace is 60,000 BTUs. The largest commonly available heat pumps is also 60,000 BTUs. So those just barely cross right in the middle. And what we find in Cleveland is if you do a load calculation to see how much it's going to take to heat and cool a house, and you do it well, so you're using the air leakage, you're using the actual energy bills, you're not standing across the street holding up fingers to see how many will cover the house. So, 3 fingers is 60,000, 4 fingers is 80. And I'm only kind of joking.
Yeah, that's a common practice.
Kind of how it happens. It's all gut. Like, oh yeah, I've been doing this for years. This is how we do this. Like, yeah, but you don't do it with any science behind it.
Right. And when was the last time you took, like a continuing education course on those things?
Yeah. So nobody knows that. But you start doing your load calcs, and very consistently, houses here in Cleveland. So, I mean, this is not a warm climate. We're not crazy cold, but we have winters where we spend 2 months below freezing. So it's not gentle. And you're from Rochester.
From Rochester, New York. Yeah.
That's the same climate, basically. We're almost
lake
the same
effect.
number of heating degree days.
Exactly.
Yep. So when you look at a house that's 2,000 square feet or less, most houses can be heated with a 3-ton heat pump, which is 36,000 BTUs. So the appropriate piece of equipment is smaller than the furnace you can buy. So you end up using a heat pump. And that was kind of how this all began. Like, wait, this is the wrong piece of equipment. Because the other thing you want to do is if you want to provide really good comfort, you want to give a trickle of heat or cool. So the easiest analogy for this is probably, say you want to get clean. And I give you the option, you have 10 gallons of water either way. I either have a giant bucket, 10 gallons, to dump over your head all at once.
Yeah, I see where we're going.
Or you can take a 5-minute shower. Yeah. Which one would you rather have?
Certainly the shower, yes.
Okay, no ice bucket challenge for you. Darn.
I mean, I've done the ice bucket challenge. And, maybe if I was that hot, Yeah,
it was an unpleasant thing.
Maybe 5% of the time I'd choose the bucket, but
there you go.
95.
But the analogy holds for a house where most furnaces are 3 to 4 times as large as they need to be when it's very cold outside. So for both of our climates, it's about 5 degrees is where 99% of our year we are above 5 degrees in both our climates. Or your home climate, not California.
Yes, I'm here in California now. Very different.
Yes, very different climate. But 99% of the time, you're above that temperature. So if it's 3 or 4 times bigger than it needs to be when it's insanely cold outside, how much bigger do you think it is than it needs to be when it's 50 outside?
Yeah. Like, so did you just kind of stumble? You said, that you just discovered it. You stumble upon it. Were you looking for a better alternative? You finally did the load calcs and did the energy modeling on the front end and said, wait a second, Eureka, there is no gas furnace out there that's doing the right thing.
It's not that far from the truth. So my business partner who lives in Rochester, like we were talking about just before the show started, he did his mom's house about 10 years ago, and they put a hybrid in her house. So a hybrid is a heat pump on top of a furnace. Okay. So an air conditioner is basically half a heat pump. It's a heat pump that only goes one way. It can only cool. A heat pump for residential HVAC means it will heat and cool. So it goes both ways. And so he put a heat pump on top of a furnace, and then on a 5-degree day, and his mom's house was built about 1980, about 3,000 square feet. She called him and said, "Hey, Teddy, it's okay. Like the house is warm, but the air coming out of the vents is kind of cold." And he in his mind is instantly like, son of a, they didn't tell the thermostat that the furnace existed.
Oh.
So it only knew that there was a heat pump, and the heat pump was heating her 3,000 square foot house on a 5-degree day in Rochester, New York. And he's like, why do we need a furnace? This is stupid. Because the operation costs aren't necessarily all that different.
Yeah.
You're within a couple $100 a year for most of the country with our, if you're talking average energy costs. So that was his first eye-opening thing. And then the whole idea of trickling the heater cold out, it's called mean radiant temperature. So mean radiant temperature, it's the average of all of the surfaces around us, and that is actually how our bodies determine if we're comfortable or not. We have 150,000 temperature sensors in our skin, mainly in our extremities, hands, face, feet, that tell us if we're comfortable or not. And so what you want to do is get all the surfaces, so all the walls, the ceilings, the floors, the furniture, all of that stuff in your house, you want to get it as close to the same temperature and as close to the thermostat temperature as you possibly can, and then you will get comfortable. And you can do that with air by trickling small amounts of heat or cool into the house to match what it needs. So it's that shower instead of the bucket.
Well,
So
so
where most furnaces
for
are a bucket,
instance,
it's a problem.
yeah, if you don't mind my jumping in here for a
No,
second,
please do.
like when my wife and I are in the car,
Mhm.
you know, she is very affected by temperature. I seem to not be. It's odd. But you know, she'll flip it all the way, you know, to the AC. And then, you know, 2 minutes later, then flip it back to the heat, you know, and I'm always thinking like, oh, well, what if we just found that happy medium? Is this that same situation just applied in a home?
It is largely. So the key difference between a house and a car is we don't leave our houses outside baking in the sun and let the interiors get to 120 degrees before we get in them. So cars have that first big lift when you get in and it's hot and sunny outside. But in general, yes, it's you're just trying to match rather than let's go all the way hot and then all the way cold and back and forth. Like let's just set it to where it's a good happy medium and let it rip. But to do that, you also need basically a throttle with the HVAC. So it can't be on off. That's single stage equipment, and that's about 85% of residential equipment. So the odds are in your attic or crawl space or basement right now, you have a single stage piece of equipment. You can't provide good comfort. That is that ice bucket sitting in your mechanical space, wherever that is. What you want is a throttle. You want that shower. So you want to be able to give it 25% throttle or 50% throttle or 100% throttle. But 100% throttle needs to be matched to what the house actually needs on that hottest or coldest day and not be 3 to 4 times what it actually needs. And so by doing that, we ended up figuring out, a modulating heat pump that modulates down to 25% of full capacity is a really good fit for most applications. And like it's kind of mind-blowing when you start figuring it out. And then you also think about renewable energy is getting cheaper and cheaper. We're on a downward cost curve.
Right.
So like oil and gas, those are stable technologies. Frack gas is as cheap as we have seen in 40 years, and frackers are not making money. They're starting to have trouble getting loans because they haven't made money for so long. So the odds of natural gas prices going down are basically zero.
Yeah.
It's not going to get a lot cheaper than where we are. Where renewables, when you look at solar and winds, they're like flat screen TVs. Their costs are plummeting. So are batteries. So they have further down to go. And at this point, we're basically at cost parity, operation cost parity between the two. It's within 20%. So, it depends where you are. It could be a little better, a little worse.
Well, and that's for the appliances to some degree too. I mean, when you're looking at, like you said, that smallest gas furnace versus the largest or a right-sized electric heat pump, you're looking at a pretty similar cost as well. Am I right?
Yeah.
And that's something that people, I don't think, know. They think they're twice as expensive or 5 times as expensive,
They can be. So this is part of why we have ended up coming into this through the HVAC side, because the program we have developed is aimed at HVAC contractors, but it's for them to work with homeowners. So we really have 2 clients in that. We have contractors and homeowners, and our big goal is we want to provide very good experiences for both of them. And if we do that, we win.
What are
But a
some of the
lot.
conversations that you've had, when you're trying to talk to other HVAC contractors about this? What are some of the responses you get? Are they excited to hear about it? Are they, dismissive? I mean, what's the general
Um,
reaction?
so it depends where you are. So like Southeast is predominantly all electric.
Yeah.
So they're used to that. But so we should back up and take a look at climate zones
Right.
in the U.S. So climate zone 1 is basically Miami and Hawaii, and that's basically it.
Tropical.
Yeah,
Tropical.
basically tropical. They've been talking about doing a climate zone 0, which would be like Costa Rica or something like that.
Oh, wow. Okay.
Where it's 70 degrees, 80 degrees all the time.
Yeah.
So climate zones 1 through 4 are not too severe of winters. Climate zone 4, you're starting to get where the winters are cold; they're not frigid. Climate zone 5 is the first cold climate zone, and that's where Rochester and Cleveland are, as is Chicago. Climate zone 6 is getting quite nippy. So you're probably going to spend a substantial number of hours below 0 in climate zone 6. So that's like Minneapolis. And that's basically, very few people live above climate zone 6 population wise. So there's some, but not a lot. And then there's climate zone 7 and 8. And 8 is like northern Alaska. So
Alaska, yeah.
crazy.
And 7's like most of Canada, right?
Yes. Yeah. 6 or 7. It depends. But anyway, if you're talking climate zones 1 through 4, heat pumps have been a pretty good solution there for 50 years. I mean, that's my business partner's good buddy just pulled a heat pump out of his mom's house in Rochester that was 40 years old.
Wow.
But he has a Muni there, so he gets 4-cent kilowatt hours. So he doesn't care. It doesn't matter. Like, yeah, it uses 30,000 kilowatt hours a year. Who cares? Like, it doesn't matter. He got a Tesla Model 3, and he loves it. He basically pays nothing for fuel anymore.
Wow.
Because 4-cent kilowatt hours are obscenely cheap. California is like 20.
Right.
We're 13, and 13 is basically the national average. Anyway, so the latest generation of heat pumps that came out in the past 10 years or so, where they're starting to get popular, they're called inverters. Those can now handle climate zone 5, the whole thing, pretty easily, and a good chunk of 6. So 6 is harder. You need to get houses tighter and better insulated for a heat pump to be a really good match there. There's a big issue with heat pumps is as it gets colder outside, their output drops. So like at 0 degrees, it may only be kicking out half of its rated output. And that's a problem because you need more than its rated output at that point. And you make up for it usually with resistance backup heat. So not meaning to get technical, but a heat pump, it's just like your air conditioner, only it's actually pulling heat out of the cold air, which seems strange, but your refrigerator is doing that right now.
So is that what you mean when you're saying the dual mode then?
Yes,
It's got that backup, so it can put out what needs to be put out in that event.
Yes. Yeah. So the backup, it's resistance electric. So think of it like your toaster, only on steroids. So a toaster is usually 700 watts. Backup heat strips are usually 7,000 to 15,000 watts.
Okay.
So toaster on steroids, and sometimes they're known as toasters. There's like 20 different names for it, like everything in construction. So we can all talk about the same thing, and none of us know what the other one's talking about. Yeah. Use a different name. Anyway, so to tie all this back, heat pumps now work really well in climate zones 5 and 6. And because of their outputs matching what the houses need, they're the best piece of equipment to solve most client problems. And you can't run a furnace on renewable energy. So a heat pump is electric, so you can run it on solar and wind, which are getting cheaper.
Yeah.
And they're clean. So the sustainability part is twofold. One, we're converting houses to run on clean energy, and the grid's getting cleaner day by day, and the math is getting so freaking good. It's insane. Like Michigan and Colorado both opted to shut down coal plants like 10 or 20 years before their retirement, because it was cheaper to stop running the coal plants and build a solar plant and then operate that solar plant at the same capacity than it was to keep running the coal plant.
That's
That's
incredible.
how good the math is. So whether we want it to or not, the math is going to force us to go clean in the next decade. So we might as well convert everything in our lives to run on it. And then the second piece of the sustainability part is, I don't know what it is with me, but I love old houses. And I don't like new ones. I just don't. They're soulless boxes for the most part, built by the cheapest bidder, and so my favorite houses are 1900 to 1945.
Nice.
Because they have soul, they're really well built, they're beefy, they've got all kinds of cool little built-ins, and they're just everything about them is just nicer than newer houses, in my opinion. But they're horribly leaky and inefficient, so they
Right.
need somebody like me. But if we can take that house and make it up to modern standards, I think we can agree that's pretty darn sustainable versus tearing it down and building a new one.
Yeah, we talk about adaptive reuse and renovation, quite a bit on the podcast, because really I've heard that is they've done the math on that one, and that's the number one way we can sort of mitigate climate change and the carbon footprint is by building fewer new construction. And obviously when we do, when there are opportunities to do new construction and the site says you have to, or there's nothing on the site already, then great, let's do a net zero building. Let's, have it be all electric, in new construction. But yeah, I love the idea that you can take something that was not designed was designed for an energy grid that existed a long time ago, and basically
didn't exist at all.
yeah, well, exactly. And say, hey, let's create something new. I also love the idea of smart grids, and the more people that have all electric appliances and solar panels, the more we can start as a community and as a society to sort of take some of that power away from the existing infrastructure and the players in that existing infrastructure, and say, you know what, we can do this better ourselves. And there's some empowerment,
Definitely.
no pun intended, but there's some empowerment there for people. And that's something that I really think, we were talking about education awareness a little bit, and that's obviously a big thing that you're doing as well, is just educating people and saying, hey, there's a better way. So tell me a little bit more about the reactions that you get when you're talking to those guys.
Just where I wanted to go back to the contractors. So, well, I should ask you a question. Did anyone in your family have an American-made diesel car in the early 80s? Do you
Not that I'm
remember any
aware of. I
experiences there?
don't think so. No.
Okay. They were despised
Yeah.
because they were such horrible pieces of equipment. I had a professor in college who worked at GM as they were coming out with a diesel engine, and like a diesel engine works pretty differently from a gas engine. But the powers that be decided, well, we're going to take this 454, which is their standard big V8, and we're just going to make it a diesel, but we're not going to engineer it. And it was a turd. It was awful. My dad had a 1983 diesel dually Chevy, and he restored cars. So he had to tow this big trailer with a car in it. The truck wouldn't break 50 miles an hour on the highway. That's horrific.
That's bad,
one time going up a hill, towing our boat, it just stopped and started rolling backwards with the engine screaming.
Oh my gosh.
And he was furious about it. It took him 30 years to buy another diesel.
Yeah.
That experience is how most cold climate HVAC contractors feel about heat pumps. They tried one, it broke on them, they got tons of complaints, they went and did callbacks, they lost a bunch of money, they pulled it out. They despise heat pumps. In fact, Chicago, I don't know what happened. I haven't found the backstory yet, but you literally cannot buy a unitary heat pump, which is like instead of an air conditioner, you get the heat pump version. So I'm not talking mini splits where it's like a little head that sits on the wall, like in a hotel room or something, but a unitary heat pump, like a standard air conditioner. You cannot buy one in Chicago. Nobody stocks them anywhere. What is that? The third largest city in the US, and you can't even buy a heat pump. And here's the problem with that. 87% of residential HVAC replacement is emergency. So if it's not in stock, it doesn't get installed. And every 6 seconds, a new piece of residential HVAC is started up in the US. And every 6 seconds, we lost that opportunity to electrify that piece of HVAC until 2035 or 2040. So like, we need to be going now.
Yeah.
If we want to do that now.
Yeah.
But we have to start with those HVAC guys, because if they aren't comfortable with heat pumps or with hybrids, do you think they can talk a homeowner out of that?
No, certainly not. Yeah.
Well, yeah, they can. I mean, they can talk a homeowner out of a heat pump all day long, including Sunday. Like, it's just not a problem.
Exactly. Yeah.
I mean, they will totally stop that sale from happening.
Right.
Like, oh no, you don't want that. So it's
right.
It's
so
like
they're not even
diesels.
being presented with the option.
Exactly.
Not even the correct information, but even the option itself. Say you got a smart homeowner who maybe has done a little bit of research and actually is open to the idea. Then they encounter that situation, and I guess business as usual. Stick with what works, but that's
exactly.
not.
It's we've always done it that way.
Yeah.
It's the most dangerous phrase in the English language, because there's always a different way to do things, and usually better.
Let's flip it around. Yeah. Can you give an example? There were a couple on your website, a bunch on your website actually, that you deemed houses of the future, which I thought was really cool because both of them were built in that time period you were talking about, 1900 through like 1920 or so.
Yep.
And one was cool because, I very rarely hear about people installing ducts as a retrofit. I mean, normally, if you don't have ducts, then you're going to try to do something else or figure out another solution. So can you talk a little bit about one or the other of those case studies on your website and maybe like a positive experience? So despite all the haters, let's bring it back to.
You can do it.
Yeah.
Well, let's touch on both of them.
Sure.
So this is EnergySmartOhio.com. There's a bunch of case studies. Go read them. It's not about selling. It's about just telling the story. So the 1900 house of the future, that was this little tiny house, 1,300 square feet. And the homeowner was somebody that I had worked for back in my insulation contracting days, and we revolutionized how his house worked. So he called me. He's like, Nate, I bought a new house. I want to make it really well insulated. I want low operating costs, and I want it to be comfortable. Like, okay. And I get there, and like, he was tired of having a boiler and the heat that it put out. I got there, and there's a hole on the basement floor where the boiler used to be. You can see the outline in the concrete. And then all of the pipes are cut. Like, this is May. I'm like, Paul, you are committed to not having a boiler anymore, aren't you? He's
so
like,
he took it out himself. He did all that himself.
That's incredible. I got there. I'm just like, my jaw is on the floor. I'm like, well, I guess we can't use that system anymore.
He was ready for a change.
He was. So the problem with his house was like 2 stories. The first story is easy if you have a basement. You put the system in the basement and you run the ducts to the floor. Not a big deal. Very common in the whole Midwest. But the attic is a problem, or the second floor is a problem, because unless you're going to totally gut rehab the house and run ductwork through the floor between the first and second floors, you don't have anywhere to go. So we took the chimney out because we didn't need it anymore. Right. And we ran the trunks up through the chimney and then ran them out into the attic and then back down through the ceiling. And it was interesting because the HVAC was running before the insulation was done. So I measured the air conditioning temperature coming out of his ducts, and it was coming out at like 78 degrees, but it should have been coming out at about 55.
Yeah.
So that's what not having enough insulation does.
Wow.
So
there was that much infiltration of air in the system
coming in. Well, I mean, if you think about it, if you have uninsulated ducts running through an attic, attics on a hot day can easily hit 140, 150 degrees. Wow. All that heat's trying to get in. So it doesn't take much to warm it up. So we spray foamed those ducts, which will be a bit of an anathema in California. But like I tell everybody is, I'll put my projects up against your projects. Use whatever method you want. Yeah. May the best man win. I'm going to win.
Yeah. Well, and just a quick aside, when we're talking about sustainability, everybody wants a silver bullet. Everybody wants the one solution that's going to work for every building type, for, every climate or whatever. And that just doesn't exist. And again, it brings it back to, You need people. You need people who know how to do the job right and who know how to think through the process and the integration of those systems that you were talking about in a building earlier, and apply the proper solution for the proper project. And really, at the end of the day, you know, we can talk cost savings on specific projects. We can talk cost savings over time on specific projects, but there's no way to just in 5 minutes round up, you know, what you're going to save, and that's what everybody asks. Well, what am I going to save?
What
You
am I
know,
gonna do?
I'll let you get back
actually,
to it.
yeah. So two points to that end. So we talk about there being 4 buckets that the problems that we solve fit into. So there's comfort problems, there's health problems, and there's moisture problems. Those are the good ones to aim at.
Yeah.
Because they're usually worth money. They actually have some real pain behind them. Like, it's something that is worth solving. The one that you don't want to talk about is efficiency, because as soon as you mention efficiency, it's what's the payback?
Right.
And the payback on our projects is generally between 50 and 500 years. We had one that we modeled and we laughed. Well, we had one, the payback said 997 years. And at 1,000 years, it says not applicable. So we were just like, sweet, look at it. And that's sold and executed.
That's great.
Like, the savings, it's never going to matter again. So I haven't seen anybody really write about this yet, but renewable energy is the cheapest energy source that mankind has known ever.
Yeah.
Like, it's really important to realize that. Like you could say wood, but if you put any value on your time, I have a wood stove in my house, and during lockdown, you know, we had extra time, and my in-laws brought their splitter over. And so I was splitting wood and then heating the house with it and seeing what happened. And it was really interesting to learn how it ran. But I also learned that it took me between an hour and an hour and a half per day between splitting wood, moving the wood, bringing it inside, stoking the fire, you know, adding wood. And so even if you value my time at $15 an hour, which is on the low side, you're talking 22, 25 bucks a day. And resistance electric heat is $10 a day. And that's one of the most expensive forms of heat. So wood is not cheap if you actually take everything into account. But anyway, renewable electricity is going to be the cheapest energy source we've ever known. So efficiency really doesn't matter that much to a large degree. Like it does, because we don't want to have to be building 3 times the number of turbines and solar panels and so forth. Like, we don't want to do that. But from a cost perspective, it doesn't really matter anymore, unless it's an application like a hospital where there's just insane usage anyway.
Yeah, I was going to bring it back to commercial buildings. Yeah, I mean, maybe there's a delta there.
Yes.
You know, if you've got huge buildings like that.
Yeah. I mean, if you've got energy bills that are really substantial, you know, like $5,000, $10,000, $20,000 a month, yeah, there's something to play with. But the average house is $2,000 a year for electric and gas. So there's not much to save to speak of there.
So it's comfort, and give us the other 3 again.
So it's comfort issues. So like common one is when you walk upstairs and you feel that you're going into another climate. It's 10 degrees warmer on the 2nd floor. As you go up the stairs, you feel it hit you in the forehead as you go.
My mom and dad's house.
Yeah, well, there you go. Yeah, like almost everybody has an example. 2-story houses, that's a problem.
Yeah.
Then there are health issues. So if anybody has allergies or asthma or mold allergies or chemical allergies, those can generally be lessened with a carefully thought out project. And then the other one is moisture issues. So in Rochester and Cleveland, we have ice damming problems where you end up with icicles in the gutters, and that can dump water into the house. But like, bugs are always related to moisture. If you have bugs in your house, there's something wet somewhere, pretty much for sure. It's a case of just about all things. Mold, mildew, all those sorts of things caused by moisture. So those are good things to aim at to fix.
And you gave a talk recently about the, you know, relation to air quality and the systems that you're designing, and how important that is in our post-COVID era here as well. I mean, that's not in those initial buckets necessarily, but health obviously is one of them. So that's a new thing to add to that bucket for sure.
It is, although we've always thought about the virus side of things, really, anyway. So that was, I assume you're referring to the Badass HVAC presentation.
Yes. Yeah.
Is
I
that one?
watched
Yeah.
a presentation that Nate was part of with Green Home Institute out of Grand Rapids, Michigan, and Brett Little, who I actually interviewed either last week or the week before for the podcast. And
Oh, awesome.
yeah, so we have a mutual acquaintance there. Yeah. Badass HVAC. Tell us a little bit. Oh no, now I have to make this an explicit episode of the podcast.
Well, just bleep it. It'll be funny.
It would be funny.
You're talking about HVAC and there's bad bleep HVAC.
That's awesome.
So the reason we gave it a cheeky name is, again, we are trying to appeal to HVAC contractors.
Right.
So, I mean, HVAC contractors in general. So, I mean, they're a conservative bunch. So politically, you have to think about that a little bit.
Mm-hmm.
And B, they're usually not the cleanest mouths, we'll say. And nor am I, to be frank. So like, if you want to get their attention, you probably want to make them laugh. And if it's a little bit on the obscene side, that's a good thing. But it does stand for something. It stands for big air drop, which is the drop where the return air comes back into the system, the big duct, where we put a big filter in it. So big air drop air source system.
Nice.
And air source system means that's an air source heat pump, where geothermal, as you might hear it called, which isn't actually geothermal, it's ground source,
right,
is where it pulls its heat and cool from. But badass HVAC, it was meant to stick, and it kind of has, and it works by far the best because, or it works by far the best with a heat pump, because the heat pump can provide far better dehumidification if it has the right control strategy. So if the thermostat has things underneath the hood that most people are never going to care about, but I do, if you run a heat pump only system, you can get these really good dehumidification capabilities.
Mm-hmm.
And the biggest thing that we have found that affects air quality, aside from a little bit of outdoor air, is humidity levels. So if humidity gets too high or too low, you really need to deal with those if you're going to deliver that comfortable, healthy, and moisture resistant house.
And that's in that 40 to 60% humidity ish range. I know there's some back and forth on that, but
yeah, there's back and forth on that. I don't like that range because 60% is higher than where I'd ever like to be if I can avoid it. And 40% in the wintertime is a very bad place to be in a cold climate, because you'll be talking about dew point. So dew point is when the air is completely full. So that's 100% humidity. The dew point, I forget exactly where it is, but it's somewhere in the 40 to 42 degree range.
Okay.
So if it's 10 degrees outside and you're running 40% humidity inside, if that 40% humidity air touches anything that's below 42 degrees, it's going to condense. And so if there's any dust or dirt, which there always is going to be, you're going to be feeding mold and mildew and moisture and other things. So 40% is too high for a lot of cold climates. So it's a nuanced conversation, like everything. So you hear 40 to 60. I wish they'd said 30 to 50 and I'd be on board.
Okay.
But 40 to 60, no, not signing the petition.
Well, based on your recommendation, from now on, I'm going to say 30 to 50.
There you go. That's generally pretty safe. So in the wintertime, we aim for 30 to 40 in a cold climate. So California, you don't have to worry about that.
Yeah, we're all right
here. In a warmer climate or in summertime, 40 to 50% is a good place to be. You're probably going to be drier than that almost all the time there anyway, because it's a dry climate.
Yeah.
You don't have as much moisture in the ground and the air as we do here, or you do back home.
One of the things I think is interesting, we talk a lot on the podcast about passive design, and what's fantastic is that here we are, to some degree, talking about passive design. Like we're integrating what is a mechanical system, but we're taking into account the natural environment when we're thinking and processing, how to implement that mechanical system. And so it's not all or nothing. I mean, speak a little bit to that about some of those things you mentioned, dew point, but when you're taking all the climate zone and the natural heating and cooling elements of the earth and the surrounding environment,
Okay.
how are you able to design a better system, a better mechanical system?
Got it. So I was trying to decide if you were talking about like passive solar-ish, like
A little bit,
or
yeah.
passive house, because those are
Oh no, not
quite different things.
specifically passive house, but
Okay.
I mean they share some principles.
Yeah, they
Just
are.
the idea. Hey, you want to harness as much of the wind, as much of the not for turbines necessarily, but like
Yeah.
to ventilate the home and things like that. And so I'm assuming you can kind of integrate some of those passive ideas with the actual mechanical system, to some degree.
Yes and no.
Okay.
So here's the curse.
Yeah.
Put some air quality monitors in, and they will break all kinds of things that you thought were true. You start measuring stuff, you're like, well, it should be like this, but it's not like that at all. So in a dry climate, you can probably flip between windows open and windows closed.
Hmm.
In a humid climate, it's actually very problematic. Um, so you may open the windows, and if it's very humid at all outside, that moisture that previously you had pumped out and you were keeping out with the HVAC in a reasonably tight envelope, now that moisture is coming back in. And then when you close the windows, that moisture soaks into everything,
Hmm.
and it activates volatile organic compounds. So your air quality gets way worse when you close the windows up. And from watching air quality monitors, it takes 3 to 7 days to pump the VOC levels back down to where they were before you open the windows.
Wow.
So that's a problem. And then also, if you are in a place with poor air quality, so the top 10 worst air quality cities in the country for particulates, the first 8 are all California. So good job, guys. Good job.
I'm
But
in a
usually,
special little area of California called Santa Monica, where our prevailing
good
winds
area.
come right off the ocean. So,
Sweet.
it's also interesting to note, with that no silver bullet thing, that
Yeah.
those air quality thing, in big cities like Los Angeles, they're measuring it, in a couple places in downtown, and
Yeah. Yeah.
that's where they're getting that number extrapolated out over the whole of greater
Yeah.
Los Angeles, and you probably have thousands of different readings depending on which way the
There
wind's going
can
and all
be,
that.
but so if the top 8 worst are California,
Yeah,
ninth and
then
10th are usually Pittsburgh and Cleveland. Sometimes Cincy's in there, so sometimes you get Cincinnati.
well, good job to you guys then too.
Yes, we are sucking it up, making air quality worse one day at a time. But so if your outdoor air quality is poor, you also need to have the house closed up. So the point is, an HVAC system should have the capability of keeping the air inside the house healthy. And then if you want to open the windows, you can.
Mhm.
But in general, and it's a very frustrating realization, if you live in a humid climate, you should probably keep your windows closed, pretty much whenever the weather's nice, which is obnoxious and not a fun thing to figure out. So it doesn't mean I like it. And a lot of my clients totally ignore me. And one of them in particular, she's awesome. So she fixed one house, electrified it. And then her parents, her dad had some health issues. So she wanted to have them closer. They were 3 hours away. So she moved them up right down the street, and then fixed another house up right up the road.
Hmm.
So her mom keeps the house closed up all the time. And my client keeps the windows open all the time. And my client's air quality readings are horrible compared to her mom's, and it's the same system.
Yeah.
Like the numbers are really similar in both houses. So it's one of those things that's hard to figure out, or it's hard to find out. So it's going to depend where you are. So
Yeah.
where you are in Santa Monica, you're probably fine. Like, it's dry, the air is clean, let it blow.
Yeah.
But if you get a house to where it's pretty efficient, like, air conditioning costs shouldn't break $200 a year.
That's incredible.
In fact, might be more like 100. So it shouldn't be anything that really bothers anyone, at least cost wise. But yeah, it's a challenging thing. Another thing I'd suggest looking up, actually, and in fact, you might want to have her on, Linda Wiggington,
Okay.
and ping me if I forget to give you more info. She is So there's the godfather. She would be the godmother of the building performance industry. So, I mean, she's forgotten more than I'll ever know. And also happens to be just a particularly sweet person. She's got a hard edge to her, but you don't see it very often.
That's awesome.
She's just a very kind soul. So she started the big group in the big trade show that I really kind of cut my teeth in.
Okay.
But she has started a program in Pittsburgh called ROCKUS. It's reducing outdoor contaminants in indoor spaces. So they've been doing these cohorts. She has a pretty good particle monitor that she puts inside the house, and the same particle monitor, which is also pretty good, another one outside the house, and then a third one inside the house, just to make sure that, you know, the readings on one of them aren't totally crazy. And she found the same thing that we did. You need to have a really good filtration system on a house, and you generally want your windows closed if the outdoor air quality is bad. And the curse about knowing whether outdoor air quality is bad is it could be good and bad 3 times on the same day.
Right.
So like there is no way to be sure of it. So unfortunately, windows closed is, according to the science and the measurement that I've done, the best way to run in a humid climate. And if you get down south anyway, like you get to South Carolina or Florida, you think they run the windows open this summertime?
No, definitely
Heck,
not.
no, that's their winter. I joke that wherever you live, you spend 3 months of the year running from the house to the car. So in Florida, it's summer. In Cleveland and Rochester, it's winter. California or Hawaii or Central America in the mountains, you're good to go. But that's about it. There's not that many climates that are that nice. So congratulations on finding one. But in general, I guess the kind of the key point to pull all that back together is we're going to need HVAC in almost all climates, almost all the year. We get our shoulder seasons for 2, 3, 4 months of the year, something like that. But the rest of the year, the other 8 months, you're going to need heating or cooling, depending on what climate you're in. So Badass HVAC is largely about showing a very simple system that's pretty easy to sell, pretty easy to install, that works in basically every climate zone and provides very good comfort and very good air quality without being extremely smart. Because if you want to control your air quality with residential HVAC equipment, good luck. It doesn't exist yet. It's coming. But we've largely found that it's not that critical. If you run your fan all the time, your furnace, your air conditioner fan, and you've got, what you're going to do is you're going to run all that air in your house through the filter. And we like to pipe in a little bit of outdoor air. So if the fan's running, a little bit of outside air is coming in. And then by mixing, if you get one room that's a little warmer or cooler than the other ones, if you mix it, you're basically treating the house like a vinaigrette and stirring it all the time. And so just the simple act of running the fan, which used to be really expensive. So the old school fans, was PSC is the name of it. They burned 500 to 1,000 watts when they were running, pretty much no matter what you did to them. But they also didn't care if you gave them a bunch of back pressure. So if you made them work hard, they were just like Mongo. Okay, this is fine. I'll just go a little bit slower. It'll be okay. And then the modern fans, the ECM fans, are more like a prima donna European football player, where you touch them on the shoulder and they're like, oh, just like, you're being stupid. Like they're very sensitive. So you have to be careful about the install. But you don't have to be that careful. You just need to know a few things. So we're trying to popularize a system that naturally provides better comfort, naturally provides better air quality, and also naturally leans towards being all electric.
Well, and if I could jump in for a second, you know, I've heard from other professionals, not just in the HVAC space, but other sort of green building when it comes to materials or other processes, or, you know, some of these things that are trying to scale and trying to gain momentum. That same thing, that really, you know, if you say, hey, go check out the HVAC 2.0, Google HVAC 2.0 for anybody who's listening, and for anybody who's in the sales space in green building at all, in any number of products, because really what you do is lay out a really good plan for how to have a background in sales. So a really good plan for how to say, listen, I will totally sell you this. And that's what you have right now. And it'll continue working. However, I can't get behind it when it comes to comfort. I can't get behind it when it comes to health, and I can't get behind it, but for a nominal fee, 250, $300, whatever. I would love to do an in-depth, I worked in the fitness industry, and that's the same thing we did. We said, hey, listen, I'll sell you a gym membership for sure. And you can come in here, but how many other gyms have you been at in the past where you stopped going? And why was that? And let's really examine that. And then what I can do is I can set you up with a trainer and a training program. It's going to cost a little bit extra, but what it's going to do is set you up for success, where you now know how to use the gym in the right way, and you understand why all of these machines are here, and you understand how to move your body in a functional way. So, you're a king of metaphors, I have to say. So hopefully that one fits in nicely there.
No, that's a really good one. Thank you. Yeah, it's as humans, we think in analogies a lot of the time.
Yeah.
So it's is one of the best ways to get a point across. I mean, I think about the pastors that I've known through the years, and they always start off with a personal story about their life that somehow magically manages to morph into what their subject is for that week. Because you need a story, you need a comparison usually for most people. But that was amazing, actually, how you put that, because that's very much how the 2.0 process is set up. So if you're okay with it, let's touch on it for a minute. Because anybody out there who wants to steal some pieces of this, please do. It'll be challenging to flesh out. Ask me how I know. If you want to not make a ton of money for a decade, this is a really good path to tread. This has not been the most profitable way. I should have sold my soul and gone to work in the corporate world, and I'd be retired already. Anyway, so the way that our process works, I think of it to some extent like going to the school nurse. So say 100 kids go to the school nurse. 80 of them are probably going to be, treated for something minor, given a Band-Aid, given an ibuprofen, whatever, and sent back to class. That's the people that are going to do a simple change out for HVAC. Like, you're not going to interest them in anything. So you've got this, we'll give you the same size stuff and you can roll on. And like you said, like no guarantees, no nothing. It'll work. Like it will turn on and off when you ask it to. That's all we're doing here. Then the next level is going to the hospital. But it's not necessarily like a critical thing. It's like, all right, we need to run some tests and see what's going on, and try and diagnose it and figure it out and see if we need to do more tests beyond that. And we think that about 20% of people will go that way. So 20 kids out of 100 would go that direction. And 15 or 18 of those kids would get some specialized bit of treatment, but it wouldn't be that big of a deal, which in this case is let's put in a better piece of HVAC, like a badass kind of system where we can actually help you with those problems. So that process is where the whole goals, house needs, and budget come in. We call it a comfort consult. And out of the comfort consult, most of those, like I said, about 15 are probably just going to go buy HVAC, and it will help fix a lot of their problems. And if we make sure that a heat pump is part of every one of those systems, whether it's a hybrid or a straight heat pump, at least that's huge. And then for the couple of stragglers, we're like, man, this kid's really messed up. Like, it's time for the ICU. We're going to have to cut them open. We're going to have to figure out what's going on. That is the process that we designed our deep retrofits for, like we were talking about with the 1900 house where the guy ripped his boiler out before it got there and all that. And we ran the ducts up through the attic and spray foamed them and then blue cellulose on top.
Spray foam for the water situation. And
Yep. Yeah, so that was all. That's a pretty intense project, but I only expect a couple % of houses to actually go that far. But because the process is built to handle those really bad ones, imagine having a hospital with no ICU. You're just like, please don't have anybody come in that's really sick. Please don't. Like, they're going to die. Like, you need to have the ICU. So we figured out the first working intensive care unit. But then we realized we only have an ICU. We don't have a hospital or a clinic. So HVAC 2.0, through the HVAC contractors, it gives us a way to cover the whole spectrum. because all the houses that found me are these really messed up houses where people had tried repeatedly to try and fix something, and they're like, we've spent 10 grand, nothing worked, what do we have to do now? Like, well, for starters, we got to spend 5 grand undoing what you did, and then we can start doing it right. So you just wasted $15,000.
Yeah.
And I hate telling people that. I've had to learn to be a little bit of a sadist in what I do, but that is not my natural personality. I don't want to say, you're a freaking moron, you just pissed away $15,000. I hope you're looking forward to working for another year before you retire because of that decision. That's not a nice way to put it, but that's kind of the facts, you know? In figuring out the whole 2.0 process, if you know that you can confidently march into any house that has any level of difficulty of problem, are you more comfortable offering solutions that otherwise you wouldn't?
Right.
So that's what we needed. Or taking a step back to my Young Life days, which is it's a Christian high school outreach group, and they're very good at strategy. So their strategy is you want to be able to reach the kid in the back of the room. Yeah. So if you're bringing somebody into a meeting and you need to design for the kid who just took his hit of pot on the way in and got dragged there kicking and screaming by his buddy, if you can reach that kid, you get the whole rest of the room.
Nice.
So I very much view it as if we can hit the house in the back of the room, we'll get everybody else. But for starters, we had a process that only would appeal to the kid in the back of the room. And we needed to appeal to everyone in the room. So we're there on that now, I think.
That's cool.
Point. So that's kind of the strategy and the thought process behind it.
That's awesome. I want to transition just a little bit before we close out here. You have the Electrify Everything, hashtag Electrify Everything on behind you on the wall there. Okay. And, you know, I know you're a part of the movement. Can you just real briefly give us kind of where that came from? Because it's not just you, it's you and others. And I actually attended, I think Green Home Institute did a Electrify Everything. It was like a year ago or so. Webinar that I think, I mean, you were part of that, I believe. I'm now putting
trying
it
to think what was my subject
here.
on that. Yeah. So I think that was me.
Because and so a little bit of history, and then the two main things I would love to hear from you, because a lot of people talk about when you were talking about transitioning over to solar, or not to solar, to all electric. People talk about electricity costs. We've already kind of gone over that, so we don't really need to do that. But peak loads, and I mean, how are we going to design a grid that's going to allow everybody? Because right now you hear a lot of people talk about if everybody switched over to electric right now, the grid would be totally overwhelmed. It'd be nuts. Prices would, skyrocket, peak demand would go off the hook. So that's kind of one. And then there's the other thing that people are really, not aware of, which is the health and some of the like electromagnetic frequencies and things like that, so that's not a particularly good thing, I guess, to talk about when you're talking, moving into Electrify Everything. But those are sort of the two biggest things I hear when I'm talking to folks about this is, the energy piece, and then also
EMF.
Yeah, EMF, and how do we stay safe? Is it safe to have so many electrical appliances and devices in our homes, and what can we do about that?
Well, I'll start with EMF. I'm not hugely knowledgeable in this, but I've definitely touched it enough to talk a little bit about it. So first off, EMF is primarily a factor of how close you are. So I don't know exactly. It's like a factor of squares, where when you get 3 feet away from it, it's 50%, and then, it's down to 5% and another 3 feet or whatever it might be.
The parabolic curve, yes.
Yeah. So it's a proximity problem to a large extent with it. And then there's a shielding problem. And generally the higher end HVAC is pretty well shielded. Because in my understanding, one of the big issues with EMF is our power runs at 120 volts and 60 hertz, and it's the hertz that really matters. So if we have LED lights running at partial power, they'll end up running at like 240 hertz or 480 hertz. Like it'll be a multiple of 60.
Interesting.
And that can mess with our bodies. Those frequencies our bodies don't like. So there can be issues with certain things. Now, that said, I've dealt with a few mold sensitive clients, and I've talked to a few practitioners in this. So in general, EMF sensitivity starts to come into play when your body's really messed up. So for starters, you live in a moldy house where you're breathing things in, and you're setting your body off in a bunch of ways, a bunch of allergic responses, and you get to where your body is wildly out of control. And usually you're pretty miserable. And a lot of those people have to leave their house wholesale, cannot step foot in, cannot take anything with them.
Wow.
Like it's, if you get really bad on the sensitivities, that's where it goes. Now, thankfully, that's not a large chunk of the population, but they are there. My mom is moisture sensitive, actually.
Yeah.
So you start with the moisture sensitivities, the mold sensitivities, then you get some chemical sensitivities. And then if you really get bad, you start getting EMF sensitivities. So that's my understanding of it. Doesn't mean that's 100% correct, because in general, when you bring up EMF with people, like for the longest time, I'm like, this is just a bunch of phooey. Like everybody wears a tinfoil hat. Like this is crazy. Like where's the science behind it? They're like, you do this and it's bad. Woo! And I'm like, woo, it doesn't work on me anymore. That worked great when I was 8, but I'm 42. Like, shut up. Show me the science.
Exactly.
And there is at least some behind it. But in general, my understanding is you have to be in a very unhealthy environment for a fairly long time before it's a problem.
So
And
there are plenty of other
that
places to start, to basically, is what you're
so
saying.
you
That's
start
great.
by making your environment healthy, which is what something like Badass HVAC does. Because there's also a wonderful thing called the Corsi Code. It's Dr. Rich Corsi. He was in University of Texas. I think he's in Portland now. So he says we live 79 years. We spend 70 of those indoors, 54 of those in our house. So a huge chunk of our lives, and we breathe about 3,000 gallons a day. So a huge chunk of that 3,000 gallons a day that we breathe, we have direct control over because it's inside our house. So if you want to avoid the EMF and the mold and the other stuff, make your house a healthy place to be, because you can control that, and that's where you spend the majority of your life. So that's step one. So hopefully that covers the EMF side.
Yeah, for sure. I appreciate that.
The other piece is more of a policy in a giant piece. So electrify everything. It was around apparently before David Roberts of Vox popularized it. So he wrote an article with that headline, and it's a very good distillation. But the basics of it are we can either run on clean energy or we can run on dirty energy. And the only clean energy that we're really good at making as humans is electricity. So if we want to run on clean energy, everything needs to run on electricity. So we need to electrify everything. That's the basic thing. And most end uses are actually really well suited to doing that. So heat pumps are a wonderful way to keep our spaces warm. Electric cars done well, like a Tesla, are an amazing experience. I love watching so I'm a car guy. I grew up around very fancy, expensive old cars. I drove a Ferrari Testarossa and was horribly disappointed by it. I just spent my whole childhood man, I'd love to drive a Testarossa. And I drove it what a turd. Nothing happens until 4,000 RPM. It was such a bummer. But I'm a car guy, so I love how fast the electric cars are. So the top of the line Tesla Model S is the fastest quarter-mile car on the market right now. That's crazy. It's a 4-door. It weighs 5,000 pounds. It shouldn't be able to beat Ferraris and Lamborghinis and things like that, but it does. So electric stuff is not a sacrifice anymore. And that's a pretty recent change. That's the last decade that all of that has flipped. So good heat pumps have gotten good in the last decade. EVs have gotten good in the last decade. King has been getting more and more popular and really good in the last decade. So our main uses of fossil fuels, there isn't a huge benefit to using fossil fuels anymore like there was. So electrifying everything is oftentimes desirable.
Yeah.
But we have to let people know, because again, we have that 80s diesel fuel or feel of like, oh yeah, my parents had a heat pump. They hated that thing. They ripped that thing out just as soon as they could. Like it was poorly applied and it was a bad piece of equipment. It wasn't a modern piece of equipment. So if we want to move people towards electrify everything, there's some upfront education that needs to happen. The biggest thing is cooking.
Yeah.
That's the keystone of everything, because the only emotional connection that we have to fossil fuels in our houses is usually the gas cooktop, because you see it. It's nice to cook on. It's nice how you turn it up and down quickly. Like it's a nice piece of equipment. And regular electric cooking sucks. It moves slow. You burn stuff. Like it's not a good feel. But induction is really nice. But you have to get somebody to try it.
Right.
And if you can get them to try it, that means the hardest thing to electrify in their house, the stove, is no longer a problem. And then the HVAC and the water heater, they're technical problems. It's not a big deal. We need to do some math. We need to do a little homework, but it'll work fine. It's not a big deal.
And it's worth mentioning that, you know, methane, despite any political things going on right now, you know, methane tends to be, the science will tell us that it is what, like 10 times worse than CO2 in the,
20.
Is it 20 concentration of, you know, greenhouse gas, the GHG, oh man, I just blanked on the
GWP,
term.
global warming potential.
The global warming potential. Thank you. But yeah, I mean, so if you could build a house that has absolutely zero potential for any methane leakage, it'll help the environment. Methane's also really bad for us, humans, you know? And so, yeah, there's always going to be that cost benefit, you know. All right, well, I got more electric things in my home, so maybe I'm scared about EMFs. Maybe I'm not, who knows? But at the end of the day, that's way better than breathing in methane or natural gas or the byproducts of cooking with natural gas, which are also
horrible,
hazardous to human health. And I heard this other thing where, because of the weight of those gases, our dogs and children tend to be the ones that are at most at risk because they're closest to the floor. And so those gases actually end up being around the floor, which was really alarming to me to hear. So I don't know if you can speak to that at all, or, you know, just kind of piggyback on that.
Well, that piece, the gases being heavy is outside my area of expertise, so I can't really talk about it very much. But that'd probably be a good thing for the show notes, wherever the resource was that you heard that.
Yeah, exactly. I'll throw that in there.
But yeah, so as far as bad gases in the kitchen, though, like something that people don't realize is, so California has fairly strict regulations. So for nitrous dioxide or nitrous oxides, which is a common byproduct of combustion, most kitchens get to 5 to 10 times the legal limit of nitrous oxides while you're cooking with a gas stove.
Wow.
So it's really, really bad, the stuff that happens. And I remember, like, we had this really cool stove. I loved it. It actually came from California. It was an O'Keefe Merit that my wife's uncle had bought and brought back with him. And then it parked in her grandparents' house, and he moved again. We're like, so can we have it? We bought it from him. And I noticed that cooking over that thing, I wasn't feeling well.
Really?
So I actually noticed the direct effects because it burned a lot of gas. That was a big stove. It had standing pilots, which I was not a big fan of, but it was a gorgeous piece of equipment, just a beautiful stove. Yeah, when we flipped over, I didn't feel bad when I was cooking anymore. So now we have induction with a decent range hood on top. Because even if you cook with induction, you're still combusting the food. Cooking is, by definition, combusting food. So you still want to have a range hood to get those fumes out. If there's any feasible way to get out of your house, that's what a range hood and bathroom fans are very, very important from an air quality perspective, because you get the pollutants out where they're produced, and then you use the central system to generally take care of the air quality in the house.
Because you're depressurizing at those points.
Yeah. You're sucking on it. In general, not that I want to get into this, but we actually prefer pressurization for fresh air.
Oh, interesting.
You put a little bit of air in, it's not a lot, and you let it find its way out.
Nice.
In general, it will, like, if you're in a humid climate and you're keeping the air dry, if you push that into the building materials, you're going to tend to dry the building materials out. And so you can help reduce moisture problems that way. Is it perfect? No. But it's a start.
Well, and that's a pretty good, pretty fun application of sort of that integration that we're talking about, when it comes to buildings and systems and everything is, hey, if I can use, this one element to kill two birds with one stone, or three or four or whatever, then great. That's the kind of efficiency, a different kind of efficiency than the efficiency we were talking about before. It's efficiency of systems and efficiency in actual use versus just energy efficiency.
Yeah, you need stacked benefits in everything that we do. So efficiency is just one of the stacked benefits that comes along. But if you get a comfortable, healthy place to live, that's the ideal piece, and it will naturally tend towards to run on clean energy. So it doesn't suck. So it's an outcome or a byproduct rather than a goal is what we find.
Full circle, man. That's great.
Here we are.
I'll give you the opportunity to throw out, any websites, any additional links that anybody can go to if they want to check out Electrify Everything, if they want to check out HVAC 2.0, if they want to check out Nate, the House Whisperer, or Nate, the Metaphor King.
So I may have to take that one on. I kind of like that one. So I'll start with, it's just a bunch of information. So in general, you'll find my sites are much more information than there's anything salesy on them. So electrifyeverything.net, I would start with. So that is where I've collated a bunch of content I've made about electrification through the years. So that has the case studies, like we were starting to talk about the 1900 and 1918 houses. It talks about how heat pumps work, the different types of heat pumps, things like that. There's a lot of information there. So step one, electrification is usually a little scary, but if you get to know it a little bit, it's a technical problem, and it's not a difficult technical problem at that. So electrifyeverything.net is a good place to start. That has links on it that go to two of our other websites. So there's energysmartohio.com, and that is the website for our practice, which is kind of winding down anyway. So although in a very cool manner, I was thinking I was going to have to kill the practice because we're going to be leaving for a year to do van life and travel the country because we have school-sponsored homeschooling. And two of our clients stepped up and they're like, well, heck, we'll help you out. So they're going to take over the practice.
No way. That's fantastic.
So how often do you hear about clients, not just one, but multiple clients getting sucked into something? And they're awesome. Great. I love both these guys. You end up getting friends out of this process. Like that's a pretty common thing. Energysmartohio.com, there's a bunch of information there, and the case studies are probably the ideal thing. So you can see what these projects look like. So
yeah, check them out, because there's also some testimonials on there from the homeowners themselves and really the comfort and health benefits that they experience firsthand.
Yeah, we really change houses. The really consistent feedback we get is, I can't believe this is the same house. So you can really change them, but you have to hit them pretty hard. So a lot of people are like, dink, dink, dink. And we're like, I'm going to go get the sledgehammer. I'll be right back. And we get it done. So energysmartohio.com is one. And the other one, I wrote a book called The Home Comfort Book. And most of it is available free. 4 of the 6 chapters are free. So if you go to natethehousewhisperer.com, you can download those chapters. Those are, it's meant to, what I found was I went looking through about 30 different books for a book that assumed that you knew nothing about building science, but were pretty intelligent. To bring you up. So a 101 was needed. Like everything I read was 301, 401, 501. I'm like, this is too intense to start with. I can't read this. Mm-hmm. So I wrote the 101 for building science and then also for HVAC. So those are the 2 chapters that are the best ones to download free. So those are key. And then if you happen to be an HVAC contractor or an HVAC practitioner, look at HVAC20.com. So we have spent this last 10 years finding a scalable process for making healthy, comfortable homes the norm and not the exception,
Yeah.
and making them available to anybody who wants them. So we needed a contractor network. So HVAC 2.0 it's essentially a business model for selling HVAC that also sells building performance for HVAC contractors. And fingers crossed that will scale quickly in the next couple of years. Initial signs are good. All the numbers we thought that we might start getting to sales wise and closing ratio wise for these guys, they're all coming to pass.
That's awesome.
So early signs are really good. We're in alpha mode for that right now. So we aren't all the way there with it, but there is a working piece of software today.
That's awesome. Well, thank you, Nate. It's been a pleasure. Nate Adams, my 5-month-old, this is the most interested he's been in any of the podcasts that I've done so far. So you won there. I don't know if you could hear him at all the whole time, but
no, I couldn't at all.
Okay, good. He's been cooing here and there. But yeah, it's a pleasure talking to you. Really fun guy, really great writer. I enjoyed reading, all the things and prepping for this online, and just a wealth of information. So I appreciate you taking time to be on the podcast, and continued success with all your work.
And all that comes right back to you. Thank you for having me on, and thank you for all of your work, Ian.
I appreciate it.